In this video, we're going to do an exam question looking at inequalities. In the previous videos, we've seen if we multiply through by the square of the denominator, we can ensure that we're multiplying through by a positive number. So in this one, we've got to solve x plus 3 multiplied by x plus 9 all over x minus 1, strictly greater than 3x minus 5. So in this case, x cannot be equal to positive 1. So let's multiply through by the square of x minus 1. So what we'll have is x minus 1 squared multiplied by x plus 3 multiplied by x plus 9 all over the x minus 1. That's going to be greater and strictly greater than the quantity 3x minus 5 multiplied through by the square of the denominator, which is x minus 1 squared. We can cancel these and we can write x minus 1 multiplied by x plus 3 multiplied by x plus 9 is greater than 3x minus 5 multiplied by x minus 1. Bringing everything to the right hand side and setting the left hand side to 0, we're going to have 3x minus 5 multiplied by x minus 1 squared. Subtract the quantity now x minus 1 multiplied by x plus 3 multiplied by x plus 9. In the previous videos, we now saw that we could factor out, and in this case, x minus 1. So 0 is greater than x minus 1, which is common to both. That leaves us now 3x minus 5 multiplied by x minus 1. And now we've taken the x minus 1 out, so we're left with the x plus 3 multiplied by x plus 9. So we've got now 0 is going to be greater than x minus 1. We need to now consider expanding and factoring this. I'm going to get 3x squared. I'm going to get minus 3x minus 5x, which is going to give me minus 8x. And then I'm going to have plus 5. Then I'm going to be subtracting away from that x squared plus 12x plus 27. So what do we end up with? We've got now on here, and each time you don't have to write out this, but you can just deal with this and put it back in. We've got 3x squared minus x squared, which is 2x squared. Minus 8x minus 12x is minus 20x. Plus 5 minus 27 is going to give us what? Minus 22. I'm now going to take a factor of 2 out of that. So we can say 0 is greater than 2. X minus 1, and that leaves us now x squared minus 10x minus 11. We can divide by 2, so 0 is going to be greater than x minus 1, and we can factor this right here. This is going to be x plus 1 and x minus 11. So our critical values are when x is equal to minus 1, x is equal to positive 1, or x is equal to 11. So what we'll do, we'll sketch up the function y is equal to the product of those linear factors and just draw a sketch of this. So what we're going to have then is over here we'll have positive 11, we'll have 1 and we'll have minus 1. I appreciate it's not hugely accurate. We've got a positive cubic graph, so we can draw the graph and it's going to look something like so. We're going to come through here and then we're going to shoot off up here. So minus 1, 1 and 11. We're interested in when this is all below 0, when it's all less than 0. We can see that's the case, and let's put this on. We can see it's below 0 at this point here and off to negative infinity. And then we've got this point right here, which is going to be below 0. Okay, so let's consider this. What we've got then is minus 1 is strictly greater than x, or x is going to be greater than 1, yet in turn less than 11. And they are the set of values which satisfy that inequality. So quite a nice exam question. If you're new to this, I strongly suggest you go back and look at the other videos, as I've gone through it slightly quicker than the others, but all of the learning points have been in the previous videos, and this is a nice exam question that we can work through fairly efficiently.